Hi there! Welcome to a new physics lesson filled with exploration and discovery. Today our topic is vector addition and practice of problems. I wanted to do at least one practice problem so you know how to do vector addition and know what to do and get you started on these practice problems. So here we go, let's get into it. So here's one of the problems from your worksheet, your vectors worksheet. I believe it's the last problem, and you will probably see one of these on your quiz. And so you will want to be able to do this over and over again until it becomes second nature. But here's our scenario. We have a hiker that begins a trip by first walking 25 kilometers south of east or southeast from her base camp. On the second day, she walks 40 kilometers in the direction of 60 degrees north of east, at which point she discovers the Forest Ranger's tower. And so we want to determine three things, and this is kind of the whole process. I want to teach you the process of how to do these vector addition problems. So first of all, we want to draw a picture. And so we have a hiker, and she hikes on the first day 25 kilometers south of east. And so we see that here. And then the second day, she travels 40 kilometers, 60 degrees north of east or northeast. And so she gets to her tower. We want to find out the components, the x and y components, so x and y components, and we want to find the components of the total displacement for her trip, and then the magnitude and direction of displacement from base camp. And so the first thing we want to do is we want to determine the individual components of this hiker's individual locations and traveling displacements on her first and her second day. And so how do we do that? Well, to get this leg of her journey, if we were to break this up into y and x components, we're going to take this, what we're given, 25 kilometers, and we're going to use some geometry here. We're going to find that x component, and we're going to add it to this x component. We're going to take the y component from the first day and add it to the second y component. And that's going to give us what we call the resultant triangle, which we can find the overall from her start point to her end point. And so we know that if we do 25, which is our hypotenuse, cosine of 45, we will find this leg. If we do 40, 40, cosine the angle, 60 degrees, we'll get this leg. And same thing for the y components. If we do 25 sine of 45, we'll get this leg, and then 40 sine of this angle, we'll get this leg. Remember that the ultimate goal is to get this direction and magnitude of this displacement from base camp all the way to the tower. And so we have these are our x and y components for day 1 and day 2. We calculate that. You can try to calculate that real quick in your calculator. You can pause it right here and then check your work. So if we calculate it, we would get 17.6 there, 17.6 because it's a 45 degree angle. These legs are the same. 20 kilometers here, and then 34 kilometers here. So 17.6 east, 17.6 south, 20 kilometers east, and then 34.6 north. And I have a little compass up here just in case you're really bad with directions. All right, so that answers A. These are the individual components of the hiker's displacement for the first and second days. But now we want to find the components for the total displacement of the trip. So if we take these and we add them together, or in this case for the blue, for the y component, we subtract them, we're going to get another triangle. And so here's our triangle here, our new resultant triangle. We want to find this resultant right here. So we're going to add these two together, and we're going to subtract, and the reason why we subtract these is because they're in opposite directions, right? 34.6 is north, 17.6 south. So since they're not in the same direction, we're going to have to subtract them. And that's going to give us our components for the hiker's total displacement. So we calculate that. It's going to be 17 kilometers, 37.6 kilometers for the components of the total displacement. However, we want to find the resultant. We want to find the magnitude and direction from the start all the way to the finish. And so how would we do that? We're going to have to use Pythagorean's theorem, which is c squared, which is our resultant, is equal to b squared plus a squared, or vice versa, a squared plus b squared equals c squared. And so we take these numbers, we're going to calculate for them, we square both of these, add them together, and then we take the square root to get our resultant being 41.26 kilometers. So this length here, this displacement would be a total of 41.26 kilometers. We also want to find the direction though. We know that it's north of east, but how much north of east? What is our angle? So to find that, we're going to use this equation. To find the angle, we're going to take the inverse tangent, which on your calculator, it's a tangent button, it's a second. You press the second button, the blue second button, and then tangent to get inverse tangent. And then we're going to take the y component, which is 17, over the x component, which is 37.6. And that's going to give us our angle, which is 24.3 degrees north of east. Yeah, so that's, in a nutshell, how to do these problems. Again, what we're going to do, we always have to break it into x and y components. We combine them to make our third triangle, and from that we can use Pythagorean's theorem to get our resultant, and also inverse tangent to get the direction. Okay, so thanks for joining us, and see you next time.